We are talking about function operations and compositions. So we will add and subtract functions, multiply and divide functions, and find compositions of functions. A couple examples that we have here, we're going to let f of x equal 5x and let g of x equal x plus 2. So if we do addition, we say f of x plus g of x, or we can have it written like this. Basically, all we're doing is we're going to say f of x plus 2, combine like terms, and we get 6x plus 2. Subtraction, we have h of x is equal to f of x minus g of x, or f minus g of x. And here we have 5x minus, and then in this case, when we're using subtraction, we have to put parentheses around the entire function because we have to distribute the negative to every term in the second function. So we get 5x minus x, which is 4x, and then the negative 2, so 4x minus 2. Multiplication, h of x equals f of x times g of x, or f times g of x, and we multiply it and we just distribute it in. So 5x times x is 5x squared, and 5x times 2 is 10x. Division, and we have this little asterisk here, and we can talk about that in a little bit. So if h of x is equal to f of x divided by g of x, or f divided by g of x, and we can't really simplify any of the function or any of the values in the function here, so we just leave it as 5x divided by x plus 2. So that little asterisk there. The domain of h consists of the x values that are in the domains of f and g. The domain of h will not include where g of x is 0. So because g of x is in the denominator, if we plugged in negative 2 here, negative 2 plus 2 is 0, then we'd have negative 10 divided by 0. That doesn't exist. So in certain situations, we have to pay attention to not only what each function's domain is, because that's going to be limiting, but we also have to pay attention to what the final domain is and where the functions are substituted in. So some operations that limit the domain, if we have the nth root of x, where n is an even integer, we know that we can't have any negative values for x. Or if we have n divided by x in the denominator, x cannot equal 0. Some domain vocabulary, all real numbers represented by the r, or if you want to use interval notation, you can use parentheses, negative infinity, parentheses, infinity. Sorry, parentheses, negative infinity, infinity, parentheses. The parentheses mean that it's not included. All non-negative real numbers, so that is going to include 0. So this says the set of x values such that x is greater than or equal to 0, or the set of x values that belong to the real numbers such that x is greater than or equal to 0. And in this case, we have the interval notation with the bracket because 0 is included and infinity is not included. All real numbers except 0. So this one we're talking about negative and positive numbers. The set of all x values such that x does not belong or does not equal to 0. The set of x values that belongs to the real numbers such that x does not equal 0. And here we have the union, and the u in the middle means it can be in both sets. So negative infinity to 0, 0 is not included, and we want to union that with 0 again not included going to infinity. And then we have all positive real numbers, the set of all x values such that x is greater than 0. So in this case, 0 is not included. And the set of all x values that belong to the real numbers such that x is greater than 0. And then here we have 0 is not included and infinity is not included. Composite function, we have this notation up here where this is written out as f of g of x. So that's what that says. And another way that you can write it out, you can write, we know that this is g of x, so we're going to take the x value and plug it into the g function. But now we have this other bracket where it says after we do that, we take this whole function and we substitute it into the f function. So plug g of x into every x in function f. And this is just the same way, we just switch the g and the f. So g of f of x, and then same thing, we take the f of x and we substitute it into the g function.